Good morning, sir. Good morning, classmates. My topic for today is building stormwater drainage system. So, mga topics na matakal na ko is subsurface drainage system, stormwater drainage system installation, under the ray is ang roof drainage and storm drainage installation considerations. Next is ang design example of a stormwater drainage system. Under the ray is ang sizing roof gutters and downspouts, sizing the horizontal storm drain, and sizing a combined sewer. First is subsurface drainage system. According to Google, kapag search na ko, subsurface drainage system is the removal of water from the root zone. It is accomplished by deep open drains or buried pipe drains. The excess water from the root zone flows into the open drains. Most groundwater infiltration problems are easily corrected by the roof and surface drainage measure outlined in the previous sections. In extreme cases, when the building site slopes severely toward the building, or if the water table consistently rises above the basement or crawl space floor line, there is need for more complex solution to these groundwater infiltration problems. Remedies includes the installation of the following system. Sump and sump pump. It is a pit or reservoir called a sump. It can be located in the basement or crawl space floor. It is used for collecting water that is discharged by a sump pump. So, muna din siya sump pump. Karing itom dire sa ilalom. And karing container nga dako, muna siyang ginatawag na sump tank. Ana. So, ang ginabuhat daw niya is kaning gikan diri sa gawas na kaning tubig ulan nga magano sa soil sa yuta ba nga magano siya nana siya yung murag pipe dira nga connecting naga-connect padulong diri sa sump tank og diri pud sa sulod kay according man daw sa uban usually naday times na magsulod daw ang ulan diri sa wall or something ana ba or sa ato then kani siyang pipe pod connected pod ni siya diri siya padulong tong ulan na or kaning tubig nga magsulod ana sige lang maano man na siya unya diri sila padulong sa sump tank and karing sump pump nani siya certain level diri na pag sa floater niya automatic siya mag-trigger mag-on. So yun niya tong water na na dire padulong diri sa discharge dira papalayo sa sa balay. So pag magbaba na pud tong level sa tubig automatic lang pud siya mag-shut off So pag taas na pod mag-activate na pod siya para dili continuous na magtaas ang tubig So next is interior perimeter or French drain. An interior perimeter drain, commonly called a French drain, is a subsurface drainage system consisting of a drain pipe or drain tile placed in a trench below the basement slab and near the inside perimeter of foundation wall. So mo na siya tong kaganina kanin sa sulod are siya interior drainage system mo na ni siya may siyang ginakuha niya padulong gyapon na siya diri sa sump tank and then pag nagtaas ang level nag-abot siya dito sa certain level nga mag-activate ang pump niya kuha niya papalayo sa building or sa balay ang katong tubig nga naabot dito sa tank ayon dire a drainage layer is sometimes added behind wall finishes and or below the subfloor na dire tong water flow padulong dire sa interior perimeter or French drain nga ginatawag. Next, exterior perimeter or peripheral drain. An exterior perimeter drain, commonly called a peripheral drain, is a subsurface drainage system consisting of drain pipe or drain tile laid in a trench around the outside perimeter. it discharges into a ditch, sump, or storm sewer. So, money shot naman tong sa dagoy niyang sa gawas na kuan, exterior na drain. Na nagyapon ni ganina dito sa sump and sump pump. Katong sa gawas na side same lang gyapon no sila mechanism na katong kay di ba naka magit siya sa ilalom. Usually nakadikit gini siya sa murag ka level niya ang foundation siya kalalom. So pag maabot ito ang tubig, ang kay para dili magstay dito ang tubig, dili niya pa mapahumok tong yuta nga kon dito. Murag niya ang tubig padulong dito sa sump tank. Then pag magsaka pud ang level, ang water level atong sump tank, mag-automatic na pud siya tas labay na pud niya sa palayo tong tubig. Di man labay pero murag nga to. Yon. So next is interceptor drain. So an interceptor drain is a subsurface drainage system involving a drain pipe or drain tile laid in a trench between the building and an uphill surface of water. It intercepts the water and discharges it into a ditch or storm sewer away from the building. So, makita na to diri nga natay kuan diri kaning storm sewer diri sa ilalom and natay balay. Then next is ang interceptor drain. Mapansin na to diri nga elevate siya kaning siya. Pag ginato diri na pag mag-ulan, sure gid padulong gid sa balay. Maong nilang interceptor drain kay para tong tubig dito siya padulong, murag mahulog na siya dito sa interceptor drain, diretso na siya dito sa sewer pipe or sa storm sewer. Di na siya diri sa mga balay-balay. So, next is ang storm water drainage system installation. Roof water drainage installation consideration. It is most important that the gutters be installed with a definite slope towards the leaders or downspouts. This reduces the potential for collection of water that may freeze or cause corrosion. All piping must be carefully located and the system checked for leaks before the concrete is poured because any relocation or repairs of pipes would be costly. So tama tong kuan niya na dapat i-sure sa gyud na walay leak og tama tong slope niya bago siya buhusan og concrete kay costly gyud pag magkuan back job o sayang ang oras. Diri ginakuan pud niya na dapat gid siya definite with install siya with a definite slope kay para maiwasan tong pagstagnant sa tubig kay lalo na diri sa to pag mga alulod nga pag nag-stock up ang tubig pwede na siya pag may lamok ato. So next is ang storm drainage installation consideration. Pipe material for storm sewers may be the same as that used for the sanitary drainage system. Storm sewer system, however, may include pipe of much larger sizes than are needed for sanitary sewer. Building storm drains should generally be graded at least 1/4 inches per foot whenever feasible. This amount of drop per foot provides an unobstructed and self-scoring flow. So, ayon diri, may similarities lang sila sa sa sewer pipe pero kailangan mas gid daw siya mas dako ba na siya specific na size kay para tong flow sa sa tubig na gikan sa storm water is murag free flow lang siya, dili siya magbara-bara or magstagnant. Kaya usually pag gamay man gud ang pipe, pag naggrabe ang ulan, may tendency na na siya murag di gud niya makaya na. So ang tendency is mag-overflow. Siguro sa ingani nga mas dako ang pipe, mas kaya niya na free flow lang ang tubig og dili magka-overflow na Ato. So makita man siya diri sa picture na mas dako gid ang ang pipe sa storm water drainage pipe kaysa diri sa sewer pipe. So next is design example of a storm water drainage system. So man siya to mga pictures na search na ako. Diri sa alam is makita na to nga sa first sa figure 16.4 diri sa first na figure is naka slope gid siya ang kuan ang ay sa atop niya nakaana tapos diri sa ilalom ay sa dulo is ang gutter then diri sa next is naka slope gid ang mga gutter towards the leader kay para maiwasan gid ang pag stagnant sa tubig ato. So sizing roof gutters and downspouts. The size of each downspout is based on the number of downspouts and the roof area each downspout will serve. In this design, 4 downspouts will be used, each serving an area of 800 feet squared or 3,200 feet squared over 4 downspouts is equals to 800 feet squared. From table 16.4a, for a maximum rate of rainfall of 4 inches per hour, each downspout must be at least of 3 inches in diameter. Number 2, the gutter size depends on the area of the roof that each portion of the gutter serves and the slopes of the gutter when it is installed. In this design, each of the 4 downspouts serves 800 feet squared. The layout would be such that the gutter would feed into the downspout from 2 sides, so that each portion of the gutter would serve a 400 feet squared of roof area. Assuming in a 1/8 inches slope per foot from table 16.5a, which is pakita na ko niya, for a maximum rate of rainfall of 4 inches per hour, a 6 inches diameter is selected for the gutters. In metric or SI units, each of the 4 downspouts serves 75 meters squared. The layout would be such that the gutter would feed into the downspout from 2 sides, so that each portion of the gutter serves 37.5 m squared of roof area, assuming a 10.4 mm per meter slope from table 16.5b. A 150 mm diameter is selected for the gutters. Yon. Ari siya mali akong nabutan na table diri so kananta posilan ta. Sizing the horizontal storm drain. Once the roof drains or gutters and downspout has been selected and sized, the next step is to size the horizontal storm drain if one is to be used. So ari siya maroon na siya ng murag instructions or procedure ba The horizontal storm drain is sized from table 16.5a. Its size depends on the area being served and the slope at which the pipe is installed. The pipe is typically increased in size as it collects the downspouts. Next, sizing a combined sewer. So sa combined, maano na nato siya na itong pag mag-joint If the roof, downspout, or leaders are permitted by code to be connected to the building drain, which is not common, in a combined sewer, it will be necessary to convert the roof area into an equivalent number of drainage fixture units, or DFU, so that the building drain can be sized to reflect the increased load. The procedure used to size building drains for sewage waste was covered in Chapter 14. So, nado sa Chapter 14 tong procedure na A typical procedure is as follows. Typical procedures. First, a schematic sketch of the stacks, downspouts, and the building drain should be made so that the relationship of the stacks and the downspouts to the building drain can be envisioned. So, i-kon sa daw is schematic sketch daw. Murag ingani roof drain, leader, itong mga kuan. So, mo doon yung example na sa combined sewer sketch for the design example. Next, Next is the fixture units served by each stock must be converted into equivalent square feet or square meter. The code sets up a ratio of DFU and equivalent square feet or equivalent square meters. So, ako rin sa lagi ang procedure is na na sa chapter 14, pero unya na ako yung diri na katong conversion niya. Next, the total equivalent area being served by the building drain is determined by adding the equivalent area to the roof area being collected. So, muna siya tong table 16.5a. Kani pinakauna muna siya tong 1/8 inches per feet slope. Sa lalom niya is ang 1/4 inches feet slope. Then 1/2 tong sa tumoy. Na siya. Tapos ari ang table 16.18 sa right side. Klaro ba? Then, lastly, lastly, the equivalent area is based on a rainfall of 4 inches Lastly, the equivalent area is based on a rainfall of 4 inches per hour. A check of the local weather service will indicate whether the rainfall in the proposed building location is more or less. If so, then the equivalent area must be adjusted proportionately. Assume the rainfall rate in the proposed location for the apartment is 5 inches per hour. How many equivalent area would the 64 DFU equal? So, at 4 inches per hour, 64 DFU is equivalent to 1,000. 64 DFU is equals to 1,000 equivalent feet squared. If 5 inches per hour naman, 64 DFU is equals to 1,000 equivalent feet squared times 5 inches over 4 inches. So, equals 1,250 equivalent feet squared. In metric as a unit, assume the rainfall rate in the proposed location of the apartment is 125 mm per hour. How many equivalent feet would the 64 DFU equal? At 100 mm per hour, 64 DFU is equals to 93 meters squared equivalent area. At 125 mm per hour, 63 DFU is equals to 93 meters squared equivalent area times 125 mm over 100 mm is equal to 116 m squared equivalent area. So, kato. Wala na. Yan. Thank you.